The second example I'd like to work on for exponential models is straight from your textbook, question 3. Question 3 says carbon-14 is a radioactive substance with a half-life of 5,730 years. It is used to determine the age of ancient objects. A Babylonian cloth fragment now has 40% of the carbon-14 that it contained originally. How old is the fragment cloth? So in this question, let's read with a little bit more detail here. Half-life. So that means that in 5,730 years, there will be half of the material that there was originally, or half of carbon-14 as there was originally. We know that our cloth fragment is 40% of the carbon-14 that it contained originally. We need to find out how old the cloth is. Okay, so half-life. Half-life means the amount is equal to half of the initial amount. We have a number of years, which is time. We have a growth factor, or 40% here. I'm not quite sure what that is yet. I'm going to have to keep thinking about that. We need to find out how old the fragment is. So we're finding T. And then if we also go to our notes, because it's about radioactive decay, we can jump to the formula that A is equal to the initial amount times by 2 to the power of negative KT. So we've already talked about A0, the initial amount, and we've talked about time. What you need to remember is that K is just equal to some constant. We don't know what that constant value is, and it'll change depending on the substance. So this is usually something that we have to find at the beginning. And that's where I'm going to start this question. So thinking about what maths I've got in the problem that I can start using, I'm going to first go to this idea that half-life is 5,730 years. And I'm going to replace the A value with a half A0. So the amount, the initial amount, A0, will be halved when the time is equal to 5,730. So I can use this to work out what K is. Now you might be thinking, hang on, you've got two unknowns and only one equation. But that's not going to matter in this case, because what I can do is just divide both sides by the initial amount. And if I divide both sides by the initial amount, I haven't changed the equation. I have kept it balanced. I'm going to actually write that as 5,730k. I've kept the equation balanced, and I've been able to eliminate one of my unknown values by following the rules of mathematics. And now I've got to this point where there's only one other value that I don't know, which is k. My next step here, because I'm working by hand, I could just type this into a calculator and use solve, but because I'm working by hand, I'm going to write a half as 2 to the power of negative 1. And because I have the same base, I can write my equation as negative 1 equals negative 5,730, and therefore k equals 1 divided by 5,730. Sweet, I've got my k value. So let's use that k value and put it back into my original expression. A is equal to whatever the initial amount is, times by 2 to the power of negative 1 over 5,730 times by t. Nice. So I have been able able to eliminate one of the values in my expression. Now my next bit is I've got to try and work out what's t. So how can I find out what t is? I'm trying to find what is t. The other piece of information that I haven't used yet is this 40%. So 40% of the material is still left. So 40% of the original amount, 40% of what was there to start. Okay, so 40% of what was there to start simply means 40% of the initial amount. And 40% we know is 40 over 100. Of in maths is always times. And we basically find out that the amount of cloth that remains from our Babylonian cloth, the amount of cloth that remains is 0.4, the initial amount. So I can replace the amount of cloth with 0.4, the initial amount. Nice. So using that same technique as before, it doesn't actually matter what the initial amount is, because I'm going to eliminate that variable by dividing both sides by the initial amount, A0, which gives me just 0.4 equals 2 to the power of negative 1 over 5,730t. Okay, 0.4. Now, 0.4, we need to somehow manipulate that expression. I'm not sure how I'm going to do that initially. I've got to work out what I might do. And to do this, I'm going to start by taking, I was trying to do it with a base of 2. I'm actually going to do log to the base 2 of 0.4 equals negative 1 over 5,730t. And then I'm going to multiply both sides by 5,730. And let's multiply it by negative 5,730. Which just equals t. And then if I type that into my calculator, I will get an answer. Sorry, just finding my calculator again. So negative 5,730 times by just having calculator issues here. Log to the base 2 of 0.4. I get my answer. It is 7,574.65 years. 7,574.65 years old. And that is the age of my cloth.